Hi, kindergarten. So this is day one of week 6. We're just about finished with our unit. Okay, one more week after this. So let's think back to our investigation question. Why does severe rain flood some places but not others? And last week you got to see me do a video on a rain model and see why rain we're trying to see why rain floods in some places and not in others. So we noticed that Carver and Woodland playgrounds had differences, right? Which one of those differences do you think is causing flooding? Think back to last week when I did the models. Think back to which one caused the most flooding with the water levels the highest. Well, we're going to look at that today. So in some of the models, you might have noticed that the water was higher in one cup than the other. Higher water is like the flooding after the rain. If I observe that the water is higher in one cup than the other, that means whatever was different between the two cups has an effect on flooding. It also means whatever's in the cup with the higher water could cause the flooding. So in this picture, I can see that the water is higher in the cup with a covered container. That means that having covers on trash cans might cause flooding. Now, let's look at our paper and see, okay? What do you observe? Do you think that trash can covers cause flooding? What about here? What do you observe here? Do you think that the fountain causes flooding? And what about here? Do you think the color of the surfaces cause flooding? Or what do you observe here? Do you think the surface material causes flooding? Just think back to last week and what we did with our different model, okay, and think about which one might have caused the flooding. So here's our modified weather types movement routine, okay? If there is more or less severe wind, you can move your arms back and forth with more strongly or less strongly to show less and more severe wind. If it's more and less severe rain or snow, you can wiggle your fingers slower or faster to show the less and more severe. And day 2, let's think about and record what we observed in the poster together. Okay, so let's decide together where to draw the water levels on each picture. Okay, let me get out my drawing tool. Okay, perfect. So in the first one, we had the garbage can cover, okay, and I noticed that the water line with the covers was slightly higher than the one without the covers, but just a little. What about the water fountain? I noticed that they were pretty equal, not much difference. The different color surface was exactly the same. The gravel water line was pretty low and the clay water line was pretty high. So this is how I would have drawn the water levels from last week when I did the rain model. And I tried to show you those pictures when I was doing the video, but it was kind of difficult. So if you want to go back to those now and draw those water lines, that's fine. So let's keep thinking. So let's discuss whether each cup in each model shows something that could cause flooding. So let's go back real fast. All right, so do you think the garbage can covers could cause flooding? I'd say that would be a little bit odd, right? For garbage can covers to cause flooding on a playground. And plus, the water line was not much different. It was just a little bit higher. Okay. What about the water fountain? Do you think the water fountain could cause flooding? No, I don't think so either because the water line was pretty much the same. And then do you think the color of the surface could cause the flooding? No, it was exactly the same. But do you think the type of surface could cause flooding? Yeah, it definitely can. If you noticed in this model, the gravel, the line is a lot lower than the line where the clay was. So maybe we could say that the clay on the playground surface caused the flooding. So based on our models, which of the differences between the playgrounds might cause flooding? Now, we just said that we think the surface material caused flooding, and our evidence came from our model, okay? Last week when I videoed the model of the cups and pouring the water in as rain, that was a scientific investigation, okay? And we can use an investigation as evidence to our argument here, okay? If we are saying that the surface material is causing the difference in flooding, our evidence is our investigation. In our investigation, we saw that clay caused the water level to be a lot higher than the gravel did. Let's think about the playgrounds. We will look at the pictures of the playgrounds again and think about why Woodlands Playgrounds floods when Carver's playground does not. So we're looking at Carver. Okay, remember Carver, it was the gravel. They've got gravel in their playground. But Woodland, they've got clay as their surface. So if we're thinking that the clay is causing the flooding, then um, if we remember, the water just kind of sat on top of the clay, where in the gravel, some of that water went down into the gravel and it didn't let the flooding continue. So we saw higher water in our models where the trash can covers were, right? Could trash can covers cause woodland to flood? No, you know, with this, the trash can, they don't even have trash can covers, right? So that would be the opposite. Even if the water collected in here, right, it was still flooding on the outside. So no, that doesn't really make any sense. Could the fountain be causing the woodland to flood? Why or why not? Well, there is no fountain in woodland, so no, it couldn't be causing the the woodland to flood. Okay. So let's move on to day 3. So using our models, we figured out why only one playground floods. Okay. Um, and we realized it was not the fountain, it's not the garbage can covers, it's not the color of the surface, but it's actually the surface material, right? So now we're going to read about how other scientists who have used models like we have and how they um, look and use models, okay? So this is a special type of book, remember. This is a type of book that is an informational book. We don't read it from front to cover. We get this book out all the time and we just read little sections that we need at that time. Okay, so if we're talking about models that help scientists investigate the past and the future, things that have happened or not happened yet, we're going to need to go to just page 28. We're not going to start at the beginning here because we've already looked at other parts of this book. So let's think about how we've used models to investigate. How do our flooding models help us to learn about something that happened in the past or may happen in the future? So we decided to use our models of flooding and rain because we couldn't go to Carver and Woodland and make it rain there to test the flooding, right? And we couldn't take away the different items of each test and difference to see what was actually making that cause, right? So we decided to use the model so that we could individually test each difference, right? We tested the surface material by itself and we realized That is what was making that flood. So let's read a little bit of this. Models help scientists investigate the past and future. Sometimes scientists want to investigate things that happened thousands of years ago. Sometimes they want to investigate things that haven't happened yet, so they can predict what will happen in the future. When they want to study in the past or the future, scientists often make models. Even if something isn't happening right now in real life, you can make it happen right now in a model. That way, you can observe the things happening. So we've got a couple of things here. We've got an artist picture of the real T-Rex. We've got a model of a T-Rex. We've got a real person walking, and then we've got like a model walking in that shoe. Let's read about the T-Rex. The T-Rex dinosaur bite model. Scientists made a model of a T-Rex dinosaur mouth biting food. The scientists asked, was the T-Rex dinosaur's bite the strongest ever? The answer was yes. The model had a stronger bite than any animal ever. This tells the scientists that the T-Rex dinosaur had the strongest bites ever. Why did they need a model to learn about the T-Rex dinosaurs? T-Rex dinosaurs lived long ago. There are no T-Rex dinosaurs alive today. Scientists can't measure a real T-Rex dinosaur bite. Okay, and then down here, we need to make sure we read the captions when we see pictures like that. This is an artist's picture of what a real T-Rex dinosaur may have looked like a long time ago. How was the model like a real T-Rex dinosaur? The scientists made their model in the same shape as a real T-Rex dinosaur skull. They added muscles that were like the muscles a real T-Rex dinosaur would have used to close its mouth. How was the model different from a real T-Rex dinosaur? The scientists made their model on a computer. It was just a picture, not something you could hold in your hands. The model could only bite. It did not do the other things that a T-Rex dinosaur could do. So again, let's read this caption. This is a model T-Rex dinosaur. It was made on a computer, okay? So these things, we use models, right? Because dinosaurs aren't real anymore, right? They are not around, and we can't just test and go get a real T-Rex, right? They're not here anymore. So that's why we had to make that model. So scientists built a model of an animal that lived in the past to answer a question they have now about the T-Rex. Let's discuss the model. So we've read about many models that scientists have used to find out about things in the real world. Let's reflect on what we've read. So imagine you're talking to someone who does not know what a model is. How would you describe models to them? What would you tell them it was? Maybe you could talk to your parents about what a model is. Okay? Tell them about the T-Rex biting model, or tell them about the model that I used to show you the rain and the flooding. Okay? Tell them about the model with the legs, with the bug walking on water, right? Why do scientists make models instead of studying the real thing? Well, like we just learned, sometimes we can't get the real thing, or we can't go see the real thing, or maybe it doesn't even exist anymore, like the dinosaur. So we need to make a model to make it a little bit easier to show things that are hard to show. So why is it important that a model be like the real thing that the scientist wants to learn about? Well, it's really important to make sure that it's as close as possible, like the legs here. It's as close as possible so that it will react the same way that the real thing does, right? So models have been important to us as weather scientists because we can learn about flooding during severe rain, even when it's not happening. Okay, I don't want to go outside during severe rain, and I don't know where Carver and Woodland even is, so I couldn't go and see the flooding there. Okay, so weather scientists use a lot of models because they don't want to go out in that severe weather because sometimes it can get dangerous. Okay, let's move on to day 4. So our investigation question for day 4, how do we stay safe from severe weather? So we already read this book to learn how severe weather can affect people. What type of severe weather did we learn about the first time we read this book? Well, the first one's a pretty giveaway, right? Tornadoes. Okay, we read about the tornadoes and predicting them, and how scientists and weather scientists can predict those, which is really cool. So we're going to read this book again. It's important to read books many times because this time we're looking for different things, okay? So as we read today, we might be thinking a little bit differently. We know a lot more now, okay? So here's Lynn Burst. Lynn Burst is a scientist who studies weather. Lynn knows about all different kinds of weather. She spends a lot of time thinking about severe weather, which is very strong or bad weather. Lynn loves her job. She says, I like that the weather is different every day. She also likes that she can help people stay safe from severe weather. Lynn works with other scientists at a weather station. The scientists study the weather together. Lynn says it's great to be part of a team. A big part of Lynn's job is predicting the weather where she lives. She uses observations of the weather that is happening now to think about what will happen next. Many people use predictions that Lynn makes. Farmers need to know what the weather will be like so that they can decide when to plant their crops. Pilots need to know when and where it is safe to fly planes. All the people who live in Lynn's area need to know when severe weather is coming so that they can prepare. That reminds me of what happened over the weekend. I watched the weather, and the weatherman said it's going to get to freezing temperatures, and you need to cover your plants if you've planted them outside already. And I already had planted a couple things outside, so I covered them with some towels, and they ended up fine because I did that, right? So I was able to keep my plants alive and protect them from freezing because the weatherman predicted those freezing temperatures. To make a prediction, Lynn uses many types of data. She checks how fast the wind is blowing. She checks how much rain has fallen from the sky. She checks the temperature. She also looks at how the weather is changing over time. The next page shows some of the tools that Lynn uses to measure the weather. Okay, so look at some of these tools that she uses. This measures the way the wind is blowing. This measures how much rain is falling. This measures it's a thermometer, it measures the temperature, and then this tool measures how fast the wind is blowing. And this tool here takes the energy from the sun and powers these tools. So that's really cool. Different kinds of weather happen at different temperatures. When temperatures get warmer, where Lynn lives, thunderstorms can happen. These thunderstorms sometimes lead to tornadoes. Tornadoes spinning air from a cloud down to the ground. The wind in a tornado is very fast as a race car. A tornado is one type of severe weather. Tornadoes can be very dangerous. Their fast winds can lift big things into the air and damage buildings and trees. That's why it is important for weather scientists to know how to predict tornadoes. Weather scientists warn people when a tornado is coming. Lynn says her biggest hope is that people will have plenty of time to prepare when she and her team send out a warning. One winter day, the weather was warm, wet, and windy. Thunderstorms were coming to town. Lynn and her team predicted that a tornado was forming. They had to warn people about the tornado. Lynn and her team sent warnings to all the people in town. They wanted everyone to be able to prepare for the tornado. At the school, the principal told the students to stay safe and away from the windows in the strongest part of the building. When the tornado hit the school, all the students were safe inside. Luckily, no one was badly hurt, even though buildings, cars, and buses were damaged. Lynn and her team had predicted the tornado in time. They had warned the whole town, and people had time to prepare. The scientists had done a great job. Lynn says weather affects everyone, every day. Lynn says her job is interesting and rewarding because she helps people understand the weather around them. She likes using science to help people stay safe even when the weather becomes severe. Why is it important for Lynn and her team of weather scientists to predict severe weather? Well, remember, if they are predicting the severe weather, they can help other people stay safe, okay? Or just keep their plants safe, right? Like mine. Here's our vocabulary for the day. Prepare means to get ready, okay? There's lots of things we can prepare for. You might prepare for school. You might prepare dinner. And weather scientists prepare what the weather will be, right? Well, they predict and then they let people prepare. A key concept, weather can be predicted. Predicting weather helps people prepare for it. And day 5, last day of the week. The Woodland principal has learned that severe rain is predicted for the town. Here is Woodland's playground before the severe rain. This picture shows us what might happen when there's severe rain. What do you observe on the playground when there's severe rain? What do you observe? When there's severe rain, remember, there's flooding, okay? And the water levels rise so that it can be dangerous for anyone near. We know that changing the surface from solid to gravel may keep Woodland's playground from flooding. You and your, well, no partners today, but you're going to think of some other ways to keep the Woodland playground from flooding again during severe rain. So, looking at this picture right here, what changes can the Woodland principal make to prepare the playground so it does not flood? Okay, we already said that they should probably change the surface to gravel, right? But maybe you can think of other things. So we just talked about possible changes that Woodland's principal could make to prepare the playground so it will not flood. Now we will make and predict and check the predictions about which changes will keep the playground from flooding. So we can use, you've got pages similar to this, okay? They don't look exactly like this, but let's read the directions and see what we're going to do, okay? We're gonna look at the pictures of the playground before and after the rain. We're going to circle whether we think it's going to flood or not flood, okay? So these are the 5 possible changes on in your packet. So you've got adding some garbage cans, okay? You've got putting the playground on a hill. You've got changing the surface to gravel. You've got adding like some sort of like roof almost, okay? And then adding some drains. So let's discuss each change and record our predictions, and then we'll observe what happens when it rains. So do you think adding garbage cans will help? Do you think adding the playground onto a hill will help? Do you think adding gravel will help? Well, let's see. Okay, we added garbage cans. Do you see how many garbage cans there are now? Kind of a funny looking playground now. Here we go, make it rain. What do you think we're gonna see if the change works? What will we see if it does not work? Well, if it does work, the severe will be a lot less, the flood will be a lot less severe, right? If it doesn't work, the flood will be about the same. Oh, still looks pretty flooded to me, okay? That looks pretty severe and pretty dangerous for kids to go play on. I don't think the garbage cans worked. Well, let's try, what did we do here? Oh, I think we added the hill, okay? So it's on kind of a slant now, on a hill. Let's make it rain, see what happens. Okay, it helped this side of the playground, but still, if kids wanted to play over here, it'd be a little dangerous. So it didn't quite solve the problem here. All right, this time they added gravel. Let's see what happens when we make it rain. There we go. Well, that solved the problem, right? There's no flooding. This would be okay for kids to play on still. Not too dangerous, right? All right, let's see if we added a roof, what would happen? Didn't seem to do anything, right? So yeah, it might have kept, anyone in here dry, but didn't really help the flooding situation. Okay, let's see what happens if we add drains. Oh, that's a lot better, isn't it? That did seem to solve the flooding problem. Okay, it looks like the water got to go down the drains instead of just sitting on top. So that would help prepare for the floods. So we better communicate to the principal our ideas about how to change the playground so it does not flood. Okay, so we probably should tell them that they've got 2 options, right? Our 2 options to make the playground more safe and not flood would be to either add gravel to the playground or to add drains. So that's pretty good that we came up with 2 ideas to tell the principal, and then the principal can make that change, right? Good job, guys. So that's the end of the week. That's the end of our lesson. I hope you have a good time checking out the lessons for the week, and I will see you next week when we finish up. You're almost done, guys. Good job.